Oh, dope. Excuse me. Here we go with the first video for Law of Science Precalculus section 6.1, day 1. Alright, so the Law of Science basically tells us the relationship in a triangle between the size of the angle and the side opposite that angle, and the relationship between the three angles and their three opposite sides. And this relationship is this equivalence of ratios, basically the length of side A divided by the sine of the angle A, where side A and angle A are opposite each other. That ratio is equal to the ratio of side B divided by the sine of angle B is equal to the side length of C divided by the sine of angle C. So we can use this ratio if we know enough information to get one of these, and we have one of these other pieces of information. Like if I know side A and angle A, and I know angle B, I can then find side B because I have 3 out of the 4 pieces for that equation. Or for example, if I have side A, angle A, and let's say I had side C, I could then write this equation and solve for the sine of C and then the measure of angle C. So we're going to do a couple of easier law of science problems written right here. And in the next video, we'll go over what's called the ambiguous case, where you have side, and angle that's not included between the two sides. And there's a little more thinking involved there. But these are kind of the intro cases to law of science. Let's go ahead and get started. So here it says solve each triangle. What that means is you're given some information about the angles and sides of the triangle. So I'm just going to try to sketch a little picture here. So I have angle A is 30 degrees, and it's always a good idea to draw a picture first. So we got angle A is 30 degrees, I have angle B is 45 degrees, and then I have the side length of A here is 50 centimeters. All right, so I have A, B, C, these 3 angles, and then I have side A opposite angle A, I have side B opposite angle B, and I have side C opposite angle C. Now, in general with triangles, the capital letters always represent angle measures, the lowercase letters represent side lengths. All right, so the goal here to solve the triangle is to find the measure of angle C and then the side length for B and the side length for C. That's the goal. We have 3 pieces of information. We want to find the other 3 pieces of information about this triangle. And the way we're going to go about doing this is using the law of sines and the fact that we know all 3 angles in a triangle add up to 180 degrees. So first I'm going to find the angle, the measure for angle C. It doesn't need to be my first step, but it's the easiest one. So let's go ahead and do that first. So here I'm going to say C equals 180, right? The sum of all the angles in the triangle minus the other 2 angles. So it's 180 minus 30 minus 45. 30 and 45 give me 75, right? So this is 105 degrees. Right? And as long as this triangle is on a flat surface, which we're assuming is the case, then the angles must add up to 180 degrees. If we get on a round, like a spherical surface or hyperbolic surface, kind of like when you get really into astronomic numbers, like astronomy, like when you're studying stars and that sort of thing, you get the hyperbolic space, which is weird. Don't worry about that. You can learn about that way later down the road. I'm not even that good at that stuff, so we're assuming that the triangle is on a flat space, angles add up to 180. So angle C is 105 degrees. So I'm just going to put that in our diagram here. So now I can go about finding side length B and side length C. I could have already found side length B because I know the angle opposite, but now I know the angle opposite C, so I can find that as well. So to find side length B, I'm going to set up what I know from the law of sines. I know I've got 50 divided by sine of 30 equals B divided by sine of 45. Right? I'm setting up this part of the law of sines. Just that part. So in order to solve this, I'm not going to take the sine of 45. I mean, sine of 45 is root 2 over 2, and I know that, like, that's that number. But not the sine of every, there are angles where the sine of that angle isn't a nice, like, square root fraction number. And it's like this decimal that keeps going on and on and on. It's a rational number, right? And your calculator is just going to estimate it. So keep it as sine 45. So I'm going to multiply by sine 45 on both sides. Do not cancel out the signs. It doesn't work that way. And now I have b equals sine of 45 times 50 divided by sine of 30. And now we know this is root 2 over 2. We know this is a half from what we know about the unit circle and sine, right? This is like 45 degrees is pi over 4 radians, 30 degrees is pi over 6 radians, right? So it's 50 root 2 over 2 divided by a half. So it's 50 square roots of 2. We can get our calculator for the decimal approximation of that. Let's round to the 100th. And I'm just going to show you that it's going to be 50 root 2. So I'm going to go sine of 45, making sure I'm in degree mode, because we're talking about degrees. Sine of 45 times 50 divided by sine of 30. So here we go. Oh, come on, calculator. So sine of 45 times 50 divided by sine of 30. Hopefully that scroll all the way over. Hit enter. Oh, hit on instead. Enter. 50 square roots of 2. I want the decimal approximation. It's 70.71, about. So side B is about 70.71 centimeters. Because this side was given in centimeters, the other side is going to be also in centimeters. Now we're going to do almost the exact same thing to find the side length for C. Now, a lot of people, not a lot, some people will revert directly to the Pythagorean theorem here, but Pythagorean theorem only works with a right triangle. We don't have a right triangle. We have, right, it's 105 degrees, so it's obtuse. Our triangle is obtuse here. So we cannot use the Pythagorean theorem to find side C. We have to use, or the easiest way is to use the law of sines. Right, there's a way you could use Pythagorean theorem a bunch of times and find it, but we don't want to do that. Along with some trigonometry. Oh, no. So we have a over sine of a, right? That's 50 over sine of 30. Equals side C divided by the sine of side C. We're using this equation here. A over sine A equals C over sine C. Now same thing, it's the same equation except instead of B over sine 45, I have C over sine 105. I'm going to multiply by sine of 105 on each side. Put that into my calculator. C equals sine 105 times 50 over sine 30. And then give the decimal approximation rounded to 2 spots. Notice I'm not putting what sine of 105 is into my calculator. I'm typing, or I'm not writing the decimal for this. Typing sine of 105 into my calculator. So sine 105 times 50 over sine 30. And I get this 25 root 6 plus 25 root 2. I want it as a decimal, so it's about 96.59. We get 96.59 centimeters. Now, we can double check that this looks correct because the biggest angle, C, relates to the biggest side, or is opposite to the biggest side. The smallest angle is opposite the smallest side. The middle angle, this 45 degrees, is opposite the middle side, that 70.71. So it at least lines up that way for what we know about triangles. All right, let's look at problem 2 now. So for problem 2, we have a different set of information. we have A, B, and C instead of A, B, and A, right? We still have two angles, but we have a different side length. So here, I'm going to draw my triangle. I've got A is 25, B is 100 degrees, so it's like this. C is up here, and then side C down here is 20 meters. So here, right, we once again have two angles on the side, but we have A, B, and C, right? We don't have this A and A like we did before. So in order to use the law of sines, we need three pieces of information from any of these pairs of expressions. Well, we can pretty easily find angle C, and that's what we're going to do first, right? We still need to find angle C. So measure angle C. We got to say what that is. We got to find also what side B is and what side A is, because that's what's missing, right? We got A, B, and angle C up here. Just like we did last time, right? This triangle's on a flat surface. The angles are going to add up to 180 degrees. So the measure of angle C is going to be 180 minus 100 minus 25. So 80 minus 25 is 55, right? Yeah. So angle C is 55 degrees. And notice this is not to scale, this is a sketch, right? It looks here like the 25 and the 55 are the same size angle. That's just because I'm bad at drawing triangles. Obviously 55 degrees is a bigger angle than 25. Okay, now we can go about finding side A and side B because we have these two pieces from the law of sines, the C over sine C. So I'm going to write that first ratio. C, which is 20, divided by sine of C, which is sine of 55, is going to equal A over sine of A, which is sine of 25, and it's also going to equal B over sine of B. Right, just like we did here, we used the A divided by sine A equals B over sine B equals C over sine C. Here we're using C over sine C equals A over sine A equals B over sine B because we know side C and angle C, right? So now we just need to solve each of these equations for side A, side B. We're going to do that by undoing the division that's happening on this side, right? It's A divided by sine 25, it's B divided by sine of 100. So in order to solve, we're just going to multiply by sine of 25 or sine of 100 on each side. So I'm going to multiply by sine of 25 on each side. Oh, let's make that 25. Multiply sine of 25. Here I'm going to multiply by sine of 100. Right, that'll cancel. That'll cancel. I'm going to get here A equals 20 sine 25 over sine 55. And here, I'm going to get B equals 20 sine of 100, my bad, sine of 100 over sine of 55. I'm going to put both of those into my calculator, hit enter, give the decimal approximation to the hundredths, or whatever the problem's asking for. It's asking for the thousandths, you go up to 3 decimal spots. All right, where'd my calculator go? There's my calculator. All right, fraction 20 sine of 100, making sure that you are in degree mode, because these are in degrees, divided by sine of 55, boom, is 20.04. So B is about 20 point, oh my goodness, sorry, 24.04 meters. And then side C should be smaller than 20 because it's opposite the 25 degree angle. So I'm going to go 20 sine of 25 divided by sine of 55. That'll give me side A, which is 10.318, which I'm going to round to 10.32 meters. And that's that. There's a couple examples of how to use love signs. Hopefully this helps you with your homework. And yeah, let me know if you have any questions. Email or drop in on office hours. Thanks for watching. Peace.